Friends, we have three nice functions which we want to differentiate. R is a function of theta, Q is function of x, and P is function of Q. Basically, we want dr by d theta and du by dx and dp by dq. Right. So it looks like we have three functions here. 1, 2, 3, and here also 1, 2, 3. Here also 1, 2, 3. Then if we use our formula u by v, the rule of quotient, that is v u prime minus u v prime by v square, right? D by dx of u by v, then it looks like it will become little cumbersome, right? Because u itself, the numerator itself, is a product of two functions, right? It will become little bit cumbersome. So let us try to simplify this numerators first, or this denominator first in this case, and see whether we can reduce the number of expressions here. Right. Here we can notice this is in the form of a minus b times a square plus ab plus b square. Right. This one. This is nothing but theta a cube minus b cube. That is nothing but theta cube minus 1 cube. Theta cube minus 1. So basically this one is theta cube minus 1 by theta cube, which is nothing but 1 minus 1 by theta cube, which is nothing but 1 minus theta power minus 3. Right. This function is actually 1 minus theta power minus 3. So dr by d theta will become minus of minus 3 times theta power minus 4. Right. We know x power n, differential of x power n is n x power n minus 1. N can be any real number. That's what we are using. So it becomes 3 theta power minus 4. Right. So this becomes minus 3 theta power minus 4. Right. 1 minus theta power minus 3. And sorry, this is minus into minus, which should be equal to plus 3 theta power minus 4. Right. Now, if you do double differential of this is again plus 3 times minus 4 theta power minus 4 minus 1. Right. X power n, differential is n x power n minus 1. So this becomes minus of 12 theta power minus 5. If you do the double differential, we can do 3 times, we can do 4 times, whatever. So far here we have done differentiating twice. Now let us take this one. Again we have 2 parts in the numerator and x power 4 in the denominator. Let us try to simplify this numerator first. So let us do the multiplication. X square into x square, which is x power 4, x square into minus x cube, x square into 1, which is x square, x into x square, which is x cube, x into minus x, which is minus x square, x into 1 is equal to x. Right. We have this minus x cube minus plus x cube cancelling, x square and minus x square cancelling, x power 4 plus x by x power 4. We can still do some simplification. This becomes 1 plus 1 by this x will go cancel here. We will be left with x cube. 1 plus 1 by x cube, which is nothing but 1 plus x power minus 3. Now differentiating this is very easy, right? This is in the form of x power n again. So this is differentiating this. This one will anyway become 0. So minus 3 times x power minus 3 minus 1, which is minus 3 x power minus 4. If we do double differentiation, if we do one more times, this itself is a function, right? If we call this as f of x, we can still differentiate this one. Right, u double prime. That means differentiating u twice. This becomes differential of this function. This is minus 3 times, again minus 4, x power minus 4 minus 1, which is minus 5. We are using this formula only. And x power n minus 1. So minus 3 into minus 4 is just 12, x power minus 5. Right. Now let us take this example. Here, the denominator is looking complex. So this is in the form of a minus b whole cube. And this is in the form of a plus b whole cube. So obviously if we try to expand, then some things will definitely cancel out. Let's do that. A cube minus b cube minus 3a square b, that is 3q square, plus 3ab square, which is 3 cube. Similarly here, a cube plus b cube, q cube plus 1 plus 3a square b, that is 3q square, plus 3ab square, that is 3q. Now here, this minus 1 and this plus 1 will get cancelled. This minus 3q square and plus 3q square will get cancelled. We will be left with q cube plus q cube, which is 2 cube, q cube plus 6 cube. Now we have q square plus 3 here and 2 cube cube plus 6q in the denominator. Can we simplify this further? Or shall we use u by v, the rule of quotients? Okay. So the rule of quotient is this: v u prime minus u v prime by v square, right? So or we can still simplify this, right? We have q square plus 3 in the denominator also. Why? How? If we take 2q common, this becomes 2q times q square plus 3, right? This is also, and then we can cancel these two factors. So we'll be left with 1 by 2q, which is nothing but 1 by 2q power minus 1. Now it becomes very easy, right? Now differential of p. Right, if you want to differentiate p, which is p prime, or dp by dq, this is equal to half into minus 1 into x power minus 2. Again, x power 1 we are using differential of x power n is and x power n minus 1. Right, half into minus 1 into q power minus 1, which is minus 2, which is nothing but minus half q power minus 2. If you want to differentiate once more, then it becomes minus half into, again, minus 2 into q power minus 2 minus 1, which is minus 3. Which is nothing but this and this will get cancelled, and 2 and 2 will get cancelled. So we'll be left with q power minus 3 or 1 by q cube. Right, guys? So this is how, when we are given some questions which look little complex, we should try to simplify them first before applying u by v or the rule of quotient, right? Right, guys? Earlier we discussed all the rules of differentiation. When it is constant, it is 0. When it is e power x, it is e power x again. The derivative of e power x is e power x. That means the slope of e power x is equal to the value of e power x at whatever x. And power rule we discussed, derivative of x power 1 is n x power n minus 1. And constant into some function, we can take the constant out, right, when you do the differentiation. And the derivative sum rule, both functions u and v are differentiable functions. That means they are continuous and they are smooth. Then that means we can split this as sum of derivatives. And product rule is not product of derivatives. Rather, we'll take one function at a time and do the differentiation for the other. So u dv by dx plus v du by dx. Differentiation of product of two functions. And derivative quotient rule. This is the ratio of two functions, right? Then v du by dx minus u dv by dx by v square, which is nothing but v u prime minus u v prime by v square, right, guys? These are very, very important rules for differentiation, right, guys? Thank you.